Hello everybody, welcome to week 2 of Performance Engines, and I think if I remember correctly at the sort of end of the last session I put out a little inquiry that was what did you think about the level that we were doing in that tutorial, and I think the consensus was you could handle that, that was all fine. Let's move on. Let's make it a little bit more advanced in this session. So that's what I'm working on as an assumption for this one. I think what we'll do is we'll do quite a few worked examples because I'm always wary that people tell me that they've had SolidWorks experience before, and I sort of skip over the basics quite quickly because of that, and then some of the models later on, let's say, aren't modeled in the best practice or best way. So yeah, so the idea for this session is to just do some worked examples using some of the skills from the last session, building on a few more just naturally as we come across them. Initially, there's quite a lot of using the extrude tool, but it's not merely about the features that we're creating. It's more about getting practice using some of the more advanced sketching tools. So certainly some of the relation types, there's trimming geometry, which you may or may not have used before, and just setting up your sketches and then setting up your features in a sort of logical, sensible manner. So it's all those sort of side skills that aren't just simply the feature type that you're using, because we kind of looked at the extrude feature last week, but it's all those skills that you build up just by doing worked examples. So what I was going to drop into initially in terms of examples was the ones which were in that PDF that we kind of opened last week. So it's that PDF there, that week 1 to 4 topics, and what I've been doing just before we started this session is just modeling up a few of these, just getting them ready, checking that there isn't anything too difficult about them for you to do. So yeah, as far as I've got is I've completed the first one, completed the second one, just sort of modeling the third one now. But I think what I'll do is someone's asking a question, I'll just finish this intro and then I'll just address that in a sec. So yeah, as I say, what I've been doing in the background here is just modeling a few of these things up. So you can see that that's kind of the first worked example. As I say, broadly it's using the extrude tool. I mean, there's a chamfer in there as well, which is pretty simple in terms of a tool to use. But there's some sketching skills that I've used in here that maybe we haven't covered before. So yeah, someone's saying I don't have access to SolidWorks, right? That's okay. Yeah. The broad gist of this question is, will I be recording this session like I did last week? Yeah, I'll upload this session, so don't worry about that. You can watch through now. In terms of the registration code that I should be giving you, I've questioned Tarsum about those, and I don't think he's figured out the system to generate them yet. So I'm sort of waiting to hear back from him. When he figures out how to get that system working, yeah, I'll pass that on. But at the moment, it's refusing to let me log into the actual system. So yeah, it's a bit of an IT issue that we're having with that, I think. So have the majority of people got SolidWorks running now then? I just like to do this at the start of every session. If you just want to put yes in the chat, if you've got it running. Or no, as the case may be. Yeah, so we're getting a few yes. Yeah, brilliant. That's the ideal situation. I understand if for whatever reason you can't run it as we're actually running through this. As I say, I'm going to record this, I'm going to upload it, so you can run through it at your own pace or refer back to it, whatever you need to do. And you can watch it live if you want, even though you won't be able to then follow along if you haven't got SolidWorks running. So back to the start, I will keep that PDF open on my other screen just so I can keep bringing it back in. So if you want to do the same, if I'm going a bit too slow for you, you can always zip ahead. That's fine, I don't mind that. So yeah, that's essentially what we're working from. So these are quite nice little sort of 3D screen captures, just showing you all the dimensions. I wouldn't really use this style if you were producing an engineering drawing. It tends to be safer to use sort of traditional projected views. But yeah, these are quite nice for us because SolidWorks will output these if you know how to set them up. And they're quite nice just as little examples. You can see all the relevant dimensions on there, so it's quite nice for us. So producing a new file in SolidWorks. So when you come into SolidWorks, you're probably looking at that screen, or maybe if you've clicked off that, it's disappeared. But regardless, you can create a new file by clicking on that sheet of paper icon at the top. And if you want your written menus there visible all the time, just as we said last session, hover over that little black arrow at the side of the SolidWorks logo till it pops out, and then click on that pin at the end, and it will pin that menu permanently there, which allows you access to a lot more tools. It's just a more thorough set of menus. But yeah, new file. If your system's still asking you what standard you want to use, BSI standard would be fine. If it doesn't ask you and you set it last session, it's obviously remembered your answer to that question. But we want to create a part file. So we're going to click on OK once we've got part selected. Then you drop into the modeling interface. Again, you may or may not be able to see your base planes. If you can't see them, try doing a bulk select by holding the Shift key like that, and hiding or showing them depending on which one you've got yours set on. You can see most icons in the feature manager, when they're visible, they're actually shaded in. So these have got like a blue color on here. And when you've got the visibility set to off or invisible or hide, they'll just be sort of a wireframe icon, so you can quickly tell. Or you may have hide all types selected up here. I'm just trying to cover all bases here because I know certain installations of SolidWorks, they come in and the planes are hidden by default. So yeah, hopefully you can see your planes now. So this is what we're hoping to model, and just to give you a run through of my sort of workflow, I'll take you through feature by feature how I've set this up. So you can see initially I create this extrude. I'll make the planes visible. There are the planes. Initially I create this extrude. I extrude it using the mid plane option. That's why there's a plane sandwiched in the center of the part there. Then I use the chamfer tool and put that chamfer on the corner. Then another boss extrude just to create that piece of geometry there. Then another one to create that piece. And then finally a cut extrude, which I think we looked at last week. I do run quite a lot of these basic SolidWorks sessions each week, so they kind of merge into each other, but we're all doing the same thing at the moment, all the modules that I'm teaching. So hopefully, yeah, we did cut extrudes last week, I'm sure. So yeah, that's the broad sort of workflow that I use. Now, that's by no means the only way to create this geometry. It's just me, through having experience with SolidWorks, kind of visually breaking down this shape that I've been given into what I see as the most logical blocks of material, or the most logical features, if you want to give it its correct name. So yeah, there will be other ways that you can achieve exactly the same outcome as we've got there, but to my mind, that seemed like the most logical set of steps to actually get there. So back to my blank part, and we'll make a start. So extruded boss base in the feature menu, that will be our first feature. What plane do I want to sketch on? It kind of doesn't matter. I would say either the front plane or the right plane. It depends how you want your part orientated, sort of in the work area. I think I chose right plane, so I'm gonna click on the right plane there. Then it rotates my view round, so I'm looking normal to the plane. And then I'm just going to sketch sort of an L shape with the bottom bit of the L stuck to the origin. So I'll probably use the line tool. So I'll sketch a line which has got a coincident relation that sticks it to the origin there, so you can see the coincident icon that's just showing when I get near it. So I'll click there. I'll take a little note of how long this first edge is. It's 96 mil. So I want to hit about 96 mil. So I'll drag it out till those coordinates there say around about 96. I don't have to get it perfect. Click there. Up to give it a thickness, and it's about 16. So again, try and get somewhere near. Doesn't have to be perfect. And then back towards that upright plane to about there. And then I believe the height is slightly less. So I'll just kind of eyeball that. I'm not looking for a specific measurement, but I want it about there. Then when I get near to that vertical plane again, you can see it's glowing in orange when I get near to it. And I get the coincident and the horizontal relation icons visible. When they're both visible, I click again, and that point is now locked onto that plane. So it has the coincident relation relative to that plane. And then I have to close the boundary. As we said last week, you want to be creating closed boundaries most of the time when you're creating these extrude features. So I'm going to go back to the origin, one final click, and then I get my closed boundary. And then I don't need the line tool, so the quickest way out of it is just the escape key. So we're out of the line tool now. So I'm just going to use the control key and the middle button just to sort of repan my sketch so it's back in the middle of the window. Then we'll have a little look at what we're working from. So the thickness of both legs of this L are both the same. So you can see there, they're both 16 mil thick. So what I'm going to do before I get the dimension tool out is I'm going to click on that edge there. Make sure that you're not clicking exactly center on the edge, because you'll inadvertently pick the center point rather than the edge itself. So click on that edge there, hold down Control, and then do the same with that edge there. And then if I'm quick enough, I can use these quick access pop-up icons, and it's the equal relation that I want to put between those two edges. So when I click on that, those two edges will always be equal length. So I've added a user entered relation there rather than an automatic relation that the system puts in as you're sketching. So I don't want to make any more changes to do with the properties of these two edges, so I can just click on that little green arrow there. You can see I've still got the properties dialog up for those two edges, so I'm done with that now. So I can just click on the green tick. Then I'm going to get my Smart Dimension tool out and add some dimensions to hopefully fully define the sketch. So Smart Dimension tool, that horizontal long edge there, click on that, place my dimension, and it should be 96, and then do the same for the vertical as well. So that one. So in our reference, it's 30 plus 34, which clearly you could work that out, but just to illustrate a point, you can actually type formulas into this entry box as well. So if I put 30 plus sign 34 and then press enter, it will do the calculation for me. So it's good to know that you get that functionality that you get in things such as Excel or what have you. You can put a formula in there and it will calculate the value for you. So yeah, 64 tall. There's one last dimension that we have to put in, and it's on either of these two edges that we put the equal relation on. So I don't really care which one you dimension because they're both going to be the same length. So I'm going to do this vertical one, and it's 16 mil. So as soon as I do that, it sort of jumps so that they're both 16 mil. I'm pretty sure I've fully defined it, so I'm just going to check down at the bottom there. Yep, fully defined. It's a closed boundary, so I'm happy. So I can exit the sketch, which is just that blue icon at the top right. Then it should rotate my view round to a slightly more isometric way of looking at it. And I need a depth. So the overall depth is going to be 64. So I just enter that into the depth box there. And then one final thing, because the block that I'm ultimately going to produce here has got this feature which is dead center. So that's in the center of this 64 mil there. So what I want to do is sandwich my right plane down the middle of my part. So I'm going to change from blind value to mid plane in the direction 1 drop down box there. So I'm going to end up with something like that. So that looks good. So I can click on the green tick. I can OK that first feature. So next feature, I think if we go by the order that I did them previously, I just put a quick chamfer on that edge there. So the chamfer tool, I don't think we covered this last session. It's a really easy tool to use. You can actually access it up in the feature menu, but it's hidden in this drop-down sub menu which is under the fillet tool. So if you click on that, there's a chamfer tool hidden in there as well. But that's a bit long-winded as a method of activating the tool. You can literally just click on an edge in the model, and the tool is one of the options that pops up after you've clicked on the edge. So you can see the fillet one's there. That's not what we want at this point. It's the chamfer one that we want. So if you click on that, you then get a preview of what the chamfer is going to do. So if you're happy with that, I think I previously set mine at 20 mil. Yours has probably come in with a default value of 10 mil, like that. But it's 20 that we want. So change the value to 10 mil. You can have a little look at some of the options. So currently this is set to put a 45-degree chamfer on there, but obviously you can change that. If you wind that up and down, you can see what effect that has. You can flip the sense of that angle. So if I say, oh, I want a 60-degree chamfer relative to this edge, and then I change my mind and think, oh no, I want it relative to the other edge, you just click on flip. Now, obviously, with a 45-degree, it doesn't matter. It makes no difference. And it's a 45-degree that we're going to have. The other thing that you can do, you can add multiple chamfers in a single feature. So if I click on this edge, and then I click on this edge, you can see we're adding multiple chamfers in. Now, if you're not seeing them in the yellow preview on your screen, it's because probably the default setting is this setting here, partial preview only, which only gives you a preview of the last edge that you clicked on. Doesn't preview all of them. So if you want to see them all in the preview, you put it on full preview, and you can see edge 1, edge 2, and edge 3 have been entered there. Now, I don't want edge 3 or edge 2, so I just want to delete them from the blue entry box, and I can just right-click on the one that I don't want, click on delete, and it'll disappear like that. So I just want that one. I want it 20 mil, and I want it 45 degrees. So we'll OK that feature. Click on the green tick. Then I think we'll put this sort of block that has a semicircular cutout in the top on. Now I've created this as a single feature, this next thing, by drawing that semicircular shape. But there's a good argument to say you could split it down into 2 features. You could make the block initially with a sort of rectangular sketch and then extrude that. And then you could do an extruded cut into it. There are pluses and minuses to both methods. Obviously, there's a little bit more work involved, the more features you put in sometimes. But keeping the 2 bits of geometry separate from each other has some benefits as well. But for this particular instance, I've decided I'm going to merge them into a single feature. So I'm going to use an extruded boss base, and I'm going to sketch on this back face of the part. So that face there, opposite side to the chamfer that we just put on. So I'll click on that. As we said last week, it doesn't auto-rotate my view after I've done the first sketch. So hopefully most of you have customized your toolbar, put that normal to icon at the top to press. But if you haven't, you can get to it in the view orientation drop down there. And it's just that arrow with the blue plane with the black arrow coming out of it. Normal to. Now what I'm going to do, I'm going to get the corner rectangle tool. So I'm sure we said last week, in the Sketcher toolbar, you have certain tools that have got little drop-down menus at the side of them. The rectangle tool is one of those. So I've currently got mine on center rectangle, but I want corner rectangle, so I can just click on the down arrow and select corner. And then I'm going to stick the first corner, or let the system enter a constraint, a coincident constraint on that first corner, and just stick it to that point there. So click, then drag. I'm just doing this visually by eye to about there, I reckon. Click again. I don't need that tool anymore, so I'm going to press escape to get out of that tool. And then I can either dimension this and then put the curve in, or put the curve in and then dimension it. I think I'll dimension this bit of it first, and then I'll put the curve in. So, Smart Dimension tool. It is 40 millimeters wide. So if I pick on that edge there and put 40 mil for that, and then pick the vertical edge at this side and put 28 for that. So you can see currently it's fully defined, but I'm about to add some extra geometry in here now, so that might change. And what I'm going to do is I'm going to get the circle tool, the center point circle tool, which again, there's various types of circle, or there's just two in actual fact. There's a perimeter circle that takes 3 clicks. You can see that. You just click 3 times, and each one of those clicks defines a point on the circumference of the circle. Or there's the one that we're going to use, which is first click is the center, second click is the radius, or the size of the circle, if you like. And I'm going to click in the center of this line, so you can see when I get near the center of it, the center point becomes visible. So first click is there, drag it out a bit to about there, click again, and then hit escape because I don't want the circle tool again. I press escape twice there to fully get out of the tool. So you can see I've got more geometry now than I need. I've got this extra bit of circle here, and I've got this extra bit of straight line there that I don't need. So there's a tool to help us with that, and it's inside the Trim Entities menu up here on the Sketch toolbar. So I don't need to go into the drop down for this. I know that might be a bit confusing given how we've been working on these. You literally just click on the icon. So just click on the scissors, and you get this dialog that allows you to tell the system what type of trim tool you want. The one that we want is Power Trim, and it's arguably the most sort of flexible method of trimming geometry. And all you do with this, so I'm going to do it in some free space over here first. I'm not going to use it properly on my geometry. You literally just click and hold with the left mouse button and just draw a freehand line. So you click in and hold in. But the key is anything that line touches will disappear, but only until it meets some other geometry. So I'll illustrate that now. I'll go through the top of this circle. There. So the circle gets trimmed back to its nearest neighbor. So that's how the tool works. So I'm going to do this bit of this line now, this horizontal line. So I'll start out here, drag freehand till I touch that line, and then it gets trimmed back to its nearest neighbor. So yeah, quite a useful tool. It just behaves a little bit differently to all the other Sketcher tools. It's that freehand type of setup that you've just got to get used to. So I don't need the trim command anymore. So I could hit escape to get out of it, or I could have click on the little green tick to get out of it as well. So we want to put some dimensions on this, and if we refer back to what we're working from, the diameter of that sort of part of that circle is 24 mil. So let's see if we can enter that. So smart dimension, click on the edge of the semicircle, and it's giving us a radius, which is not really what we want. But we'll place that dimension, and obviously we could just manually convert the radius into a dimension in our heads. But let's say, so we'll just OK that. We don't need to enter anything in there. Let's say we, for whatever reason, do want to specify this as a diameter instead of a radius. You just right-click on the diameter, on the dimension, sorry. Right-click on the dimension. You get a little sub-menu up, and display as diameter is one of the options. I'll try that again. That's interesting. It's not working. Aha, there we go. I don't know why I had to move it to get it to work. But yeah, you've got the option, is what that's illustrating. And then if I click on it again with the right click, it's changed to display as radius. So you can flick between the two as you need to. So yeah, 24 mil diameter. So this is still not fully defined. So what I'm going to do is I'm going to get out of my Smart Dimension tool. So I'll press Escape, and I'm just going to start dragging points around to try and get a sense of how this is still underdefined. So you can see there's two things that need addressing. There's the fact that the center point of the circle won't stay in line with this top edge. So we're going to address that first. So I'm going to click on the center point of the circle, hold down Control, and then pick one of these horizontal edges. Doesn't matter which one. So that one will do. And then of the relation icons that pop up, I want to make those two entities coincident with each other. So that horizontal edge, even though it's been cut, the machine will interpret it as running on forever in a horizontal sense. And so it will allow me to make that point in the center of the circle coincident with where that edge is in space, essentially. So coincident is what we want, which is that icon. So we've corrected that sort of amount of freedom that it had, but it's still free to slide backwards and forwards. So one way that we can correct that is we can put an equal relation between that horizontal and that horizontal. So the length of those two edges will always remain equal to each other. So we've done this once already in the other sketch. So if you pick one of the edges, maybe zoom in a little bit on the other one, hold down Control, pick that one as well, and it's that equal sign which represents the equal relation. And then you can see that's been entered as a green approved relation for both those edges, and it looks like the sketch is fully defined. So yeah, all the blue lines and points have turned to black, and it says fully defined at the bottom there. So we can exit that sketch by clicking on the blue icon. Then we get a preview, but it's a little bit hard to see what's happening, so I'm going to rotate my view a little bit. It's gone in the wrong direction, so I'm going to have to correct that by clicking on that reverse direction button just under the direction 1 label there. And then the depth of it we want to change. So the drawing that we're working to doesn't give a depth as such. It gives an offset from this surface. So it's saying that face there needs to always be 22 mil away from that face there. So we can set that relationship up in the extrude that we're about to create. So rather than just giving it a blind, just simple value from where the sketch is onwards, we want to change this to offset from surface. And what that will ask us by this glowing blue entry box here is basically saying you need to pick a face or you need to pick a surface of some kind to define where the offset's going to be from. So we've already said it's from this front surface here. Then what we have to specify is what we want the offset to be. So 22 in that entry box, and there you go. Now, if yours is defaulted to 22 in the other direction, which I've just switched mine to there just to illustrate the point, then there's just a little reverse offset tick box there. So you can have 22 in one direction away from that surface, or you can have 22 in the other direction. And the beauty of that is if we just OK this feature now, so I'll OK and get out of that, it will always maintain that 22 mil relationship away from there. So I'll just temporarily just drag the dimensions of my block so that it's not as I set it initially. So I'll make it much wider, let's say. You can see if the intention of this part is that it always has a 22 mil, let's call it a clearance there, then you can build that in to the actual part model itself so that it will always maintain that without you having to go in and manually change the depth of this extrusion. So I'll undo that because we don't want it that thick. So next bit, I think we'll put this little diagonal block, which is going to illustrate something which is, once you get a little bit of part geometry created, as we have now, sometimes you can put features in or you can put sketches in, certainly, that you don't require dimensions to fully define. So this sketch that we're about to put in, we're just going to lock it to some other geometry that already exists. And again, the beauty of that is it will change itself relative to the geometry around it. So if the geometry around it changes in size or scale, this sketch will adapt to that rather than putting a static value in there. So it's going to be an extruded boss base again, and we're going to sketch on what we're calling the back face here again. So we'll select that as our sketching plane. For this particular one, it's such a simple sketch, I'm not going to really feel the need to get the system to rotate my view round, so I'm normal to it. It's quite a simple sketch, so I'm going to do it from an isometric position, sort of here. So line tool, because we're going to sketch a triangle. I'm going to lock one end of the line onto that point there. So I'll let the system put a coincident on that. So I'll click, and then the next point onto that point there. Click again, and then onto the internal right angle corner there. Click again, and then back to where I started. And it's a fully enclosed boundary, so it's been shaded in, and it's fully defined without the need to put any form of dimension on it. So I'm happy with that. So I'm going to exit the sketch. So I want to click over here on the blue icon at the top right. Then I'll get a preview of what the extrude's going to do. It's picked the wrong direction again. It's kind of arbitrary. It's sort of 50-50 whether it makes the right choice for you or not. But we know how to change that, so we'll reverse that direction. Then what is the depth on the reference? It's 12, so we'll put 12 in. That looks good. That's what we want. So I'll OK the feature like that. And then we've got one final feature to put in. So it's this sort of slot shape with a radius end on it that we're about to put in this face here. So it's going to be an extruded cut that we're going to use to put this slot shape in. There is another feature that you could use for this, and in the later sessions we are going to have a look at the hole wizard. And within the hole wizard, so the hole wizard is used to create certain standard sized holes. So there's various hole standards throughout the world. There's ISO as a standard, there's ANSI, there's the popular German standard DIN as well. There's lots of different hole standards, and this software has a lot of those already programmed in. So you would go in there, you would say, right, I want a BSI is another standard in there. I want a BSI hole, and I want it to be tapped, and I want it to be M6, standard course M6 hole. So the system has all the spec to do with that already stored in there. But the Hole Wizard also stores standard slot sizes as well. So we could use that. But for what we're trying to do here, I think that's a little bit overkill. These are just tutorial parts that we're creating simple geometry. So yeah, we'll get onto that. But for the time being, we're going to use the extruded cut. So click on extruded cut. Now it's asking me what face I want to use to sketch on. I'm going to use this top face of the part here, but I could equally use the top plane. Given where the top plane is located there, I could sketch on that and then do my extrude upwards through the part. But I've made the choice in this example to sketch on the top face of the part there, so I've just clicked on it, and then extrude cut downwards through the part. So yeah, I'll probably rotate round to view this face normal 2, because it's going to be a bit easier in this instance. So normal 2, and then we've not used this tool before, but there is a tool for drawing sort of racetrack shapes. I think they're referred to sometimes, or SolidWorks calls it just a slot shape. And again, there's a few different versions of this tool. So there's a straight slot version where you just click at the center points of the 2 arcs on the ends of the slot. That's the first one. There's a center point straight slot, which is the one that we're going to use. I tell a lie. I think we'll use the straight slot. And then there's various slots that sort of curve round an arc shape as well, that are less commonly used, but you've got the tools there if you need them. So straight slot I think we'll use. Straight slot. And then I'm going to purposely not draw it in the final position because I want to add some manual relations in here. So I'm going to draw it slightly out of position first. So I'll allow it to lock itself to that center plane that I put in there in the middle of the part. So I'll lock the first point onto there. You can see the construction line just following my mouse pointer around. And then I'll let the second point lock itself onto the center line. And then the third point sort of defines the width of the slot. So you can see it's getting bigger and smaller in terms of its width. So yeah, I'll click about there. And then I don't need that tool anymore. So I'll hit escape again. And then I'll put a few dimensions in before I start adding some relations. It's 60 mil wide. So 16 mil on the width. So I clicked on the 2 vertical edges there to define the width, which sometimes when you're using the Smart Dimension tool, you just click on an edge or an entity in the sketch, and other times you click on multiple entities to define the distance between more than one. So the length along one of the flat edges is 20 mil. So I'm just going to click on that flat edge and set that as 20. And then I don't want the Smart Dimension anymore, so hit escape. And then the last bit that I want to do, I want to lock that point, which is in the center of the arc at that end of the sketch, to that edge there, so that that arc is always outside of my block. So that's not going to cut anything, that arc. It's just this end of the sketch slot shape that's going to cut. So yeah, I want to pick that center point, hold down Control, pick that top edge as we're looking at it now, top horizontal edge, and then of the relation options that pop up, which, as I said last session, if you sort of wiggle your mouse around here, that quick access menu disappears, but you can still access all the relation icons that were in it down at the bottom left there. So coincident is what I want to make those two. And then I can exit that properties dialog for the things that I've selected, so the line and the point. And then just do my checks. Is it fully defined? It looks like it is. So I'll have a look at the bottom right. Yep, it is. Is it a closed boundary? Yep, looks like a closed boundary. So, okay, that sketch. And then I should get my preview. So I'll just rotate around so I can make sense of it. Yeah, it looks good. It's not going quite deep enough, which I could just set a value in there to make it go deep enough. But I'm going to use one of the logical end conditions for this extruded cut, which I think we used some of these last time. So I want it to go through to the next surface. So I want to select that option there, up to next, which it means up to next surface or next face. So that looks good. And the nice thing about that is if that bottom leg of the L gets thicker, that slot shape will always cut all the way through. So, okay, that feature. And then that's it finished, more or less. Now, the one thing, which is, you could argue it's just been sort of fancy, is I changed the color to match the example, which can be useful. You can put false color into parts so that you can discern them when you put them in a bigger assembly. That's quite useful sometimes. Or you can apply kind of realistic finishes to parts so that if you want to take a screenshot, let's say, the overall assembly looks something like it will look when it's actually produced. So yeah, it's an easy trick anyway. So when you're looking at your part like that, if you just right click on the part icon at the top of the feature manager there, so mine's called part 4, yours will probably be part 1. So right click on there, click on that icon, appearances, which is like a multicolored ball with a pencil in front of it. And then you want to apply an appearance to the whole part. So you just want to click on the part in there. And then you get this dialog, which if you're not seeing some of the detail here, you may want to go into advanced. But essentially, you can set your part color to whatever you need to. There's some predefined colors here that's pretty close to what we want. Or you can just drag around the on the color mixer palette yourself. And yeah, the two uses over time that I've found for that is either setting up designs to look quite realistic so that you can maybe show a client or show a final customer, or just doing a little bit of false color stuff like I would describe this as, so that when you put this into an assembly, you can easily spot it and it stands out from the other parts that would be colored a different color. So I think we'll much more quickly run through the next example, which is that one. Did that cause anyone any problems? Was everyone happy with that, I suppose, is the question. Everyone happy, yes or no? I got one yes, yep. Yep, that's all okay. Nobody's got any issues with that. Right, good stuff. Okay, so we'll move on to the next one. So I think on this one, the order of how we'll do this. So I'm just creating a fresh part, which if you're not familiar with that, you can click on that little paper icon. It looks like a sheet of paper on the top menu bar there. Or you can go into the file menu and just click on new and then just double click on part. It's probably the quickest way. And then again, if you're not seeing your planes, you kind of know how you can make them visible now. So I'm not going to go through that again. So what maybe I'll suggest is I'll run through this as quick as I possibly can. I'll probably not describe much of what I'm doing. I just want to show you the way that I would model this, and then if you're sort of nippy enough, you can follow me in real time. But what I'll then do is I'll sort of go back to the start and go through it at a slightly slower pace. But I'm trying to kind of up the pace of these examples to just not lose the interest of the people that have used SolidWorks before. Just sort of accelerate our way through them as we do each one. So yeah, I'm going to jump right in, do a boss extrude, and then I'm going to create a center point slot. So this is a different type of slot. but similar to the one that we've already created. Then I'm going to put a few dimensions on it, so 56, like that, and then a width. And if I can find the width, so yeah, 18 times 2 on the width. And then I'm going to model in some holes into this, although you could use the whole feature again. And then I'm going to mirror this entity about the center line like that, and I'm going to dimension this up at 16. So that's kind of my first feature for the setup of this, and hopefully if you're looking at that off screen, maybe the reference, you'll kind of see where I'm going with this. I've created this as my first feature like that, so that's what we're aiming for. So I've kind of created that bottom piece of it. Then probably what I'd do is I'd create a new extrude on this top surface here. I'd use this center point rectangle to keep everything nicely centered around that center plane there. And then I can dimension that up. So we've got 40 there and a 10. So again, mixture of dimensions and relations. So that relation will ensure that this block is always in the middle of the first piece that I'd modelled up. Then we've got a height for this, so I'll just rotate around a bit. Might use the drag handle for that. 32. There we go. So that's the next piece. And then there's a couple more pieces here, so depending on which one takes your fancy really, you can do them in either order. I'm going to create another boss extrude on that plane, that being the right plane, and then I'm just going to draw a weird sort of arbitrary diagonal line like that. But then what I'm going to do is lock the ends of that line using the coincident again, or in this instance it's a pierce relationship, which kind of does the same thing. And then I'm going to see if I can get this one to lock itself on. No, it's not going to do that. So I'll pick the edge, pick the point, put that pierce relationship in there, like that. Now I'm going to get the line tool again and just close this shape up, so it's a closed boundary. So down to there, across to there, it all looks good, so we can exit that sketch. And switch that to mid-plane, because I want it sat in the middle of the shape. 12 mil. Okay. Extrude boss base, sketch on the top face, rotate round, get the circle tool, put a circle out here somewhere, get the line tool from that point to the edge of the circle. So I'll go a little bit slower at this point. One thing to note here is the end of my line's happy to lock itself onto the edge of that circle. You can see the coincident relation popping up there at any point. But what I want is a special type of relation which is known as a tangent. So you can see if I get to that sort of quarter circle mark, it knows that that's significant. It's offering to lock itself onto there. But if I go a little bit beyond there, you can see something else pops up, which is a circle with a line just tangent to it. That's what the icon looks like. And that is the tangent relation. That's what I want. So basically what that means is as the line comes towards the circle to meet it, there is zero angle between the two. So the line will run into the circle perfectly. There will be no sort of harsh angle between the two of them. But we'll cover that when we do this a little bit slower. So back to what we were doing. Mirror that line using the mirror command. Trim some of the circumference, and then close our shape up again, like that. And then what dimensions have we got? So we've got a 32 out to there, like that. Then we've got a 30mm diameter on there. So in this instance, maybe I won't convert it. I'll just do the conversion in my head that it's 15mm radius, and then we're good. Rotate the view a little bit. Other direction. 10mm. And then extruded boss base on the top. I want to hide the planes, which we'll talk about why you might want to do that. I make the center point visible, and then I draw the circle in. Check that the circle's constrained itself. It hasn't, so I'll have to go back in and do that manually. Circle in the edge, and it's a coordial that I want between those two as a relation. And then okay that. That's a 10mm when it wakes up. 10mm extrude, and then there's one feature left, I think. I'm just double checking. Yes, extruded cut. So I'm sketching on this top surface, getting the circle tool, I'm locking it to the center of that circle, and then just dimension that up. And then when we get the extrude cut dialog up, I'll probably do up to next, just to make sure that that goes through into that lower portion. So that's essentially the part. And then obviously you could change the color if you want. You know how to do that now. But so there were a few skills in there that I don't think we've done before. There was mirroring sketch geometry, which I don't think we'd done before. There was a couple of new relation types that I don't think we'd used before. There was the tangent relation. There was coordial in there. There was also the fact that when I was drawing this triangular wedge here, it didn't refer to the relation that it put at either end of the diagonal there as coincident. It used the word pierce instead. And yeah, I think we'll go through, we'll kind of talk a little bit about those. And yeah, so I'm going to start a fresh part. So here we go. So that first thing, that first sort of section, I'd sort of, again, broke down this in my head and thought, right, okay, how am I going to approach this? And again, there are numerous ways that you could do this. The first kind of choice that I made here is where I was going to put the origin. So where was this part going to be positioned relative to the base planes? And I kind of spotted again that it kind of has a certain degree or 100% symmetry around a theoretical center plane that passes down through sort of here. So it's symmetrical either side. So it would make sense to put one of the base planes in the middle of it there, to kind of represent that symmetry and to give us added benefits in that we can use things like mirror tools to mirror geometry from one side across to the other side. And we can use things like mid-plane extrusions to ensure that this rib, for example, always stays in the center here. So yeah, there's a little bit of analysis before you begin that you kind of want to look at what you're working from or what your design is if you've got some kind of hand-drawn designs that you're going to work from of your own. But yeah, just a little bit of thinking time before you dive straight in. So the first piece was an extruded boss. I'd made the decision as well how I was kind of going to orient this in the modeling environment. I'd sort of made the decision that the top plane in my modeling environment was going to be coincident with this underside here. So when I make that first feature, I'm sketching on the top plane. So I'm telling the system, this is where I'm going to create my first feature. I use the slot tool again, but this time I use the center point slot because again, I wanted the slot to be symmetrical around that vertical plane there. So center point slot makes that a lot easier because as you use it, as the tooltip shows you, the first click is the middle of the slot, the center, and then the second click goes out in one direction, but the other side of the slot expands in the other direction as well by an equal amount. So it means I can lock the center, the first click onto the origin there, and then drag out to the side. You can see the center line of the slot following my mouse pointer, but then drag out to the side, click again, and then just give it a width. At that point, just to get the scale more or less right before I put these circular pieces in at either end, I quickly just flicked into the Smart Dimension tool. So I just clicked on that instead. Dimension the width by actually clicking on the top and bottom edges of the slot. The width is set as a radius of the ends. Maybe I shouldn't have dimensioned the width, but it's easy enough to convert that in my head. Or if you wanna, you can say, well, the radius is 18, so can I have 18 multiplied by 2, please, like that. So either way, it doesn't matter. Then the length along the flat edge, so if you want to pick either one of the horizontal flat edges, is 56. So, so the outline of the slot now is the right size and scale. So then I made a decision, and again, we sort of talked about this already. You could argue that these holes constitute a feature in their own right, which I wouldn't argue with you if you claimed that. And one way of modeling them is to make them a feature in their own right. But yeah, we'll look at that in later sessions. Kind of in this session, we're covering these more basic sort of extrude cut tools. So we're going to model them into our sketch, essentially. So I'm going to get the circle tool, circle sketch tool, center point circle that is. I'm going to let this circle lock itself to the center point of the arc that forms the end of this slot shape, like that. Drag it out to roughly the right scale, click again, and then I'm not going to draw the other one over here, so I'm going to hit escape to get out of that circle tool. I'm going to dimension the diameter of that with the Smart Dimension tool, so click on the outer edge, place the dimension, diameter is 16, and then that's fully defined at that point. But then I'm going to use the Sketch Mirror tool. So there's a tool sort of halfway along the sketch toolbar, Mirror Entities, and it's got two entry boxes here. So the first entry box, which is glowing blue, or it should be, it may have pre-selected your circle already. If you left your circular edge clicked on when you entered this tool, it will pre-enter whatever you'd clicked on into that first box. So if you're seeing something slightly different, that might be what's happening. But essentially, this first box allows you to click on pieces of sketch geometry that you then want to mirror about either a plane or a sketched line. Yeah, so two entry boxes, anything that you want to mirror, and then what are you going to mirror them about? So we just want to mirror the circle. So you click on the edge of the circle, sort of define that you want. The system refers to it as an arc. It kind of is a special sort of arc that goes 360 degrees to meet itself. Then we're going to click in the second box, and then we're going to define that plane there, which again, placing that plane where we have relative to our sketch is helping us now, so that we can just click on that plane. We get a preview in yellow, as most of the previews are in SolidWorks. If we're happy with that, you just click on the green tick. And what it does, so I'm just having a look at some of the relation icons just to think, well, I've never seen that one before. What's that one? It's a symmetric relation. So whatever we do to this side will get also done to this side. So if we change the diameter, let's say, you can see that they change together. And that goes for the position as well. So we're happy at that point. Everything's fully defined. We've created a closed boundary that just happens to have two little bits missing on the inside, but that's okay. So we'll click on OK to exit the sketch. And then we need to give this a depth. So it's going in what I'd class as an upward direction. It's a positive Y direction. If you want to relate it to the tri-axis readout at the bottom left there, you can see it's going upwards in a positive Y direction. So what is it? It's 8 mil. And then we can OK that feature. So the next one that I did was that kind of rectangular block there. So I'd kind of split this shape down into, it has this initial plate, then it has a block of material that sort of rises up, then it has this extra material here, which itself then has a circular boss, and then there's a cut that passes through everything that sort of goes down through there. And then it's got this rib feature as well. But what I'm going to create right now is this box feature here that kind of grows out of this top surface of our initial slot shape feature. So my window's disappeared. I'll get it back. There it is. So it's an extruded boss base feature again. It's asking me what plane or plane of face I want to sketch on. I've already said it's going to grow from this top surface out of my part. So I'm sketching on there now. I could rotate my view round. In fact, I will rotate my view to be normal 2. So normal 2. And again, I'm aware maybe some people customize this interface and put that there, but I'll just take a second now to tell you again how to put that normal 2 icon up there. So if you want any icons available easily on this, I always forget the name, heads up toolbar, I believe it's called. You just right click on any existing icon. So I'll click on that one, let's say, right click, customize from the menu that pops up. Go into the commands tab, because all the commands in the whole software will be listed here somewhere. And it's the standard views option in that categories list. So standard views, and then you can just click and hold and drag it to where you want it. So maybe drag it up there. And then if you want to remove it, you just click and drag again and drag it back down. So pretty simple. And then when you're done with that, you just OK it, and it should stay there. So it's useful for putting regularly used commands in, just so that you don't have to go searching for them in the menus. So I want to draw a rectangle. I'm going to use center point rectangle tool, which is already selected on mine. You can find it in the drop down. I'm going to lock it to that center plane again. So there's a theme emerging here. I'm trying to keep all these features centered around this plane that we've sandwiched in the middle of our part. So lock it to there. And then the corner that defines sort of its scale, I'm going to lock to that edge there, so that it follows that edge always. Then I'm going to smart dimension it. So I'll do a horizontal, horizontal, which is going to be 40 mil. So 40 mil on there. And then the vertical edge is 10 mil. So that should be fully defined. So again, through smart use of the automatic relations that we allowed the Sketcher tool to put in, and through our own dimensions, we've fully defined it. And it's often the best way. If you just dimension a sketch, it has no kind of adaptability to other bits of the design changing. If you just purely use dimensions to lock everything in place. And likewise, if you just purely use relations, that there can be downsides to that as well. It kind of depends what your intention is for that feature. Should it always be coincident with that edge? If the answer is yes, then lock it in place using a coincident relation. So you've kind of got to make your own judgment based on what your intention is for that design, as to whether you use a relation or a dimension. So the depth here is definitely a dimension. So it's going to be 32 mil, and that is measured up off the top surface, which kind of explains, when I was working from this, the way that we have been given it in the drawing, if you want to call it that, is that 32mm references that top surface. So when we come to enter a value in the extrude here, it will be nice to kind of mirror how they've defined it for us, seeing as they've defined it off the top surface rather than from the top plane, which is down there. Then that's kind of why I made the decision to sketch on that top surface, because we could have equally sketched on the top plane and just referenced our extruded depth or our extruded length from the top plane. But then we would have had to have done a little bit of maths and said, well, it's 32mm plus whatever the thickness of that bottom is, 8mm. So yeah, I'm trying to stick as close to as possible as they've defined it in the picture or the drawing that we're working from. Anyway, 32mm, okay that. So we've got our next piece there. I think next we'll put that diagonal rib shape in. And again, I did that slightly differently in terms of the technique that I used. It's still an extruded boss base, so we'll click on that. But I kind of, so I'm going to sketch on the right plane because it's going to be a mid-plane extrude. So I'm going to select the right plane now. Now I'm in the sketcher tool. I wanted to just illustrate me getting the line tool there and just sketching in some random place. So just there, let's say, where the system didn't offer me any particular relations to lock this onto anything else. And then I pressed escape to get out of the line tool. And this is just showing you don't have to use the auto relations if the perspective that you're viewing something from means that it won't easily lock itself onto anything. So you can see there it's not picking up that edge underneath there is anything that it can provide a relation to lock to. So sometimes you get into this situation and you've got to manually put your own relations in. So I'm going to pick that edge, I'm going to pick that point, and the one that it offers me, the only one that it offers me, is the pierce relation, which is kind of what it says. It's the line is running through in a, what is it? It's an X direction, and I have selected a single point. So I've arguably selected a one-dimensional object, just a single point on the end of the line. And it's saying that point could pierce that line. As that line passes through in the X direction, that point can pierce it at a certain point. Is that what you want? And it is. So pierce. And then we're going to do the same with the bottom as well. So pick the point, hold down Control, pick that bottom edge, put a pierce relation between them. And then we just need to close this up. So get the line tool again. Now we're going to accept some of the system suggestions. So it's saying I can lock that to vertical if you want, which we do. And then when I get near the being horizontal to the bottom point, you can see something else pops up, which it's not going to add any relation in there. It's just giving me some information in white saying at this point you happen to be horizontal to the bottom edge of your own sketch. Do you want to click here? And essentially I do. So click. Then when I go out to this one, lo and behold, it was telling the truth. I was horizontal to this point. So click again to complete the boundary, and then that should be fully defined. Again, not using any dimensions at all. So that's very adaptable to change that particular feature. That rib feature will adapt to size itself so it's appropriate to whatever the underlying features get modified to. So if the underlying feature that is this becomes much wider in this sense, in the Z axis, this rib will follow it. So very adaptable to change if you just use relations. So I want to exit out of the line tool, so I might hit escape. And then when I'm back up at the sketch level with no sketch tools selected, I then want to OK the sketch. And it should take me into the feature definition. Yep. And I think I've already said I'm going to use a mid-plane for this. So I don't want just a blind value. I want the mid-plane, as we're doing with all these features. We're keeping them centered around that right hand plane there. So what's the width? 12 mil. Yeah, that looks good. So we can OK that one as well. And then, so we're nearly there. So what are we going to do next? We are going to create this sort of tapering block of material. So you can see. And the way that I've decided to do that, and again, there are multiple ways that you could set this feature up, but the most logical one to my mind is, again, just to create a 10 mil extrude. So you can see it's 10 mil thick of the correct boundary shape that has sort of a semicircular arc at one end, and then it's sort of it's smaller at that end, so it tapers down from the width of our block that we've just drawn to that end. So in order to create that, I'm going to sketch on the top of our block that we just created in the last feature. So extrude boss base again, pick that surface or that face on the top of our last feature there, then rotate the view round, because it's quite advantageous in this example. Then, so I'm making a specific choice here. I'm going to put this circular element in first. And the reason, you kind of saw that when I was drawing this before. When I get my line tool, I want something to be able to attach this end of the line to. I want to be able to put that tangent relation in as I sketch this first line. So in order to do that, I need a circular shape up here first. So I'm going to get the center point circle tool, hover over the sort of area where I'm in line with this plane, this right plane. You can see that when I get near it, I get the coincident relation popping up and the plane itself glows in orange. So click there, drag that out to approximately the right sort of size and shape, about there. Hit escape because I don't want that tool anymore. And then I'm just going to get the line tool and draw a line that starts at that point there. So it locks itself coincident with that. And then again, we kind of talked about this. So there's three options here. Either this line will just lock itself to anywhere on the circumference of this circle, so that's that one. It will lock itself to 3 o'clock on that circle, so at horizontal on the circle there. That's not what we want either. But if you just go slightly beyond that, you'll get that tangent icon visible, which is the icon that's got a circle with a line just touching it, like that. That's the one that we want. And if that works, you should be able to hit the escape key to get out the line tool, and you should be able to see that relation icon just sat there. And as I say, if you try and investigate what that means, hold on. If I lock the center point of this circle temporarily where it is, so you don't have to do this. This is just for illustration. So I'll lock that in position. I may lock the circle itself in position. And then I can't drag my line around. So what I'm trying to illustrate here is what that tangent, there we go. That gives you more of a handle of what tangency between one of these line elements and the edge of a circle means. So you can see there's no angle. Where the line transitions into that arc shape, there is no angle between them. So that angle of that line runs perfectly into the start of that arc section there. So that's what tangent relation means in terms of your sketch geometry. So I'm going to quickly delete those fixed relations that I put in, because they're a very crude way of holding things in position. It's not something that you regularly want to use. So what am I going to do with this? I'll probably use the mirror command again. So we used the mirror command before on those holes that we sketched out. So mirror entities, and I'll show you the opposite workflow to what we did last time. So I'll pre-select the thing that I want to use, that I want to mirror, and then I'll click on the mirror tool, and you can see it's pre-entered it into that box there. So that's kind of the behavior of how it works. Then I'll say, what do I want to mirror this about? So I'll click on the mirror about box, and I'll pick that right plane. Then I'll get the preview. If I'm happy with that, I can just click on the green tick, and that's okay. So I've got a mirrored copy that's linked back to the original. There's a couple of things I need to do now. I need to close this shape up, so I'll get the line tool, just close that back edge from there to there. So it's now closed. It's not quite closed because it's two closed boundaries. So you can see I've got the boundary that describes the circle up there, and then I've got a second closed boundary down here. So if I was to OK this, the extrude feature wouldn't like it, and it would throw an error and tell me to go back into the sketch and correct the error. So what I'm going to do is I'm going to escape the line tool and use that trim command. So trim entities, power trim, and just draw a freehand line through the thing that I don't want, like that. And it will trim it back to the nearest neighbor. Then I'm going to get the smart dimension tool. I'm going to dimension from this horizontal back edge all the way up to the center point of my arc. So there. I think that's how I'm interpreting the drawing that we're working from. It's not 100% clear. As I've already said, these 3D sort of isometric, fully dimensioned drawings are a little bit ambiguous in places, but yeah, I'm interpreting that as the center of the circular sort of feature. So 32 mil for that one. And then if we put a dimension on the edge of that arc, and can we right click here? No, we can't. So we'll place that, and then what I'm trying to do here is just convert it into a diameter first. Display options. Yeah, you can do that. So I've never tried that before. So as you're about to enter a value for it, you don't have to exit out of there to convert this into a diameter. You can at that point just right click, go down to display options and display as diameter. So you can see that's an option as well. And then we should be able to just enter the value that we want for that. So 30. Yeah, there you go. But you can always do it the other way. If you exit out while it's still a radius and then right click on it, you can modify it that way as well. Either way. So that's fully defined. It's a closed boundary now. There's no sort of double boundary thing going on. It's just one closed boundary. So we're happy. We can exit that. And then we'll set the depth. Make sure the directions pick the right direction, which it hasn't. So we'll flip the direction, set the depth, 10 mil. Okay, that one. And then there's two more left to go. So there's a circular boss shape that rises out from the top of this. And then there's a through hole that cuts through everything, that goes down through them. So it's all using the same tool. Well, similar tool, extrudes. So we know how to do this now. Extruded boss base, sketch on the top surface. For our purposes now, I'm going to temporarily turn the planes off because they're going to kind of confuse things as we put a relation in now. So I'm going to just quickly click hide all there. And I'm going to do this from a sort of isometric standpoint here as well. So center circle tool, and I think I'll specifically sketch it out of position over here somewhere, because I've seen how the system behaves when I sketch this in. So then I'll hit escape because I don't need that tool anymore. Then I'll pick the edge of the circle, hold down Control, and then I'll pick the edge of that arc there and click. And again, we're encountering a new type of relation, the coordial relation. So I could add a concentric here, but all that would do, I'll do that and then I'll undo it just to show you for reference. Concentric will just put that circle in the right position. It won't make it equal in size to this arc, so equal in radius, which is what I want. I want it to be centered around there, but I also want it to be equal in radius as well, or in scale, if you like. So there's a special relation which will achieve both of those things, which if I go back one step, it's that one. It's the coordinal, which is they're both sharing a center point, but they're also both the same scale, let's say. So yeah, coordinal does that. So we're happy with that. Just with the single dimension, we've fully defined that sketch. So we can exit and set the depth of our extrude. It's picked the right direction this time, which is good. It's even preset itself to the right depth, which is 10 mil. So that's good. So we got one left, which is the extruded cut, which there's nothing particularly advanced about this. So extruded cut, create the sketch on that top surface. So click on there, create a center point rectangle. So let's see if we can get this one auto referencing this circular edge. So if I hover over a circular element, so that can be a full circular edge or it can be an arc, you can see that little icons that mark the sort of 90-degree points of that edge pop up, and the center point becomes visible as well. So if I hover over the center point and click, and then make my circular sketch, and then click again, yes, it's put a coincident relation in on that center point. So it's done half the job for me. I still have to put a dimension on this, but its position in space has been locked down. So it's always central to that edge that it's been sketched on. So I don't need that circular sketch tool. I'll hit escape, get the smart dimension tool, click on the edge of the circle, drop my dimension, and it's 20 mil. And then we'll OK that. And then just to be different, let's have this one as through all. So we've been using up to next, which to be honest is my preference unless I specifically need through all for anything. But in this instance, through all will do what we need it to do. It's just that, I think I said it last time, the danger of through all, let's take a little thought experiment on this particular design. If it was decided at some point that these two fixing holes here weren't sufficient to hold this, whatever it is, this widget in place, and this lower first feature down here was expanded to be much bigger, so it grew and it became big enough that it was underneath this hole, then that cut would travel all the way through it. Now, if that is the intention of the design, that's fine. Through all is probably the right option, but you've just got to be aware that that is going to keep going through all surfaces in the part. It's just going to go off into infinity, cutting through whatever it encounters. So you've got to be a little bit careful when you use that particular end condition. But it'll work for us in this instance. So yeah. So that's pretty much it. And then just to keep the practice going, if you want to change the color, you can just right click on the part there, click on the little appearances icon that pops up, say I'd like to edit the entire part, and then just give it whatever color you want, and give it a nice sort of turquoisey blue color like that. And that's essentially it. So again, everyone follow that? Everyone okay with that? Just give me yeses if you are, and a no if you're not, or specific questions if you're not. It's looking good. It's looking like people are happy with that sort of level. So what I want to do is step the difficulty up a little bit now. So just let me, so I'm sort of browsing around in some of the examples that we've got here, because the intention is, we'll probably not go through every single one of these worked examples in class, but there's plenty of stuff for you to go at there in terms of putting in a little bit of practice in your own time. So I'm getting some of these JPEGs open and we'll just look through them. So yeah, that's what we're working through. There's some in the central PDF document. There's a few more in there. Probably the most difficult one is that one. There's a few skills related to that one that it may be worth us covering, because certainly these angled faces that you're encountering there kind of require a new skill, which is that you need the ability to put new planes into a part and define where those planes are positioned, and in this case, what angle those planes have relative to the base planes. So that's something that we definitely haven't covered yet. Now, there are ways to work around that with your current skills that I've given you, but by far the sort of most sensible way of approaching something like that is having that ability to produce or to create new planes that you can then sketch onto. So like this feature here, this majority of the block would have been created first, and I would interpret the majority of this block as aligning with the base planes, which you can kind of see the origin point is sat at that corner there, that little blue thing, sort of defining that that's the upward direction. That location is where the origin is. This is kind of, I think it's the Y direction in this arrowhead here. So these are kind of off kilter slightly. We're getting 160 degrees there. Yeah, so that's measured down from this vertical edge, this vertical face here, down onto that angled face is supposed to be 160 degrees. So yeah, I don't really want to cover that one at this point. So yeah, if you're going to do some of these examples, probably best to leave that one till we approach covering those sorts of inserting new planes, those sorts of skills. But there's a lot of other stuff in there. So things like that you could approach. In fact, we've done that one. We've done that one just with the chamfer. Yeah, that's sort of doable with the skills that I've shown you. Again, that's got a really nice plane of symmetry running down the center of it. So it would be foolish not to put one of the base planes running down the center of it. So you can see that center line I'm pointing at there is kind of where you want one of the base planes running. Yeah, all of these are quite simple. Again, there's a nice line of symmetry running down the center of that one. Let's see if we can see any others that haven't. That one's almost too simple to even attempt. That's I'm trying to get to some of the more advanced ones. So yeah, that one's reasonably interesting. Again, we've got a line of symmetry running down the center there. We have got something that's approaching an interesting shape there. So we've got a double curve with a radius of 55 on this piece here. And then what is the radius on the top? So it's not specified. So yeah, that one might be a bit more challenging for you to attempt. And then there's another one, if I can get my zoom menu to stop interfering with my browser window. So yeah, that one's quite interesting. That one I would say at some point have a go at. And the reason I say that is there are skills in there that would set you in good stead for elements of the project. So there's a certain element of dealing with things such as conrods in the project. So that is almost a shoo-in for practicing those sorts of skills. And yeah, it would be a good one to try. But I think what we'll do for the rest of this session, because we've got about half an hour left, is we might dip back into the PDF and see if we can find some good examples of revolves that we can do. I think we might have a crack at that one. Is that worth doing? Yes, it probably is. There's a couple of skills in there. And then we might save the whole wizard. Chamfers we've already done a little bit of. Fillets are quite easy. But yeah, I think for the next lesson we'll pencil in whole wizard stuff. and possibly some patterning stuff as well. So we've got a little bit about patterns of features there. Yeah. So in the rest of this session, I'm just thinking on the fly. I thought we had some more interesting revolves there. I think we might have a little go at that. We might touch on putting tolerances in your parts themselves. So you can see, hopefully from this drawing, so this is a more sort of traditional engineering drawing. The sort of bulk of the shape of this part has been produced not using an extruded feature, but using a revolved feature. Did we cover revolves last session? Refresh my memory. Give me a yes, no if we covered revolves. Anybody? No. Brilliant. Okay, so this is something that we didn't cover last time. But yeah, revolves are reasonably simple, and they've got a lot of similar sort of setup steps that extrudes have, but with the major difference of, instead of your 2D sketch shape being pushed through space or through 3D space in a single direction, revolves spin around a center axis. So they still move through 3D space to describe what solid shape you want to create, but rather than going off in a sort of single direction, they revolve around this center axis. So yeah, I think we may set that one up. I was sure I had some other revolves, but we'll try this one. So I'll pull that onto my other screen so I can keep bringing it back in for reference. But we'll have a go at setting that up. So let's go File, New Part. And then, so I'm just setting my other screen up. Just give me a sec. Right. So, what are we going to do first? So in the orientation that it's drawn here, we're going to sort of mimic that in our sketch that we're about to create. And the shape that we're going to create is essentially this cross-section shape here. So you can see I'm sort of tracing it round. Now we're going to disregard these slot shapes that have been cut into the part. So you can see in the 3D view of it here, it has these slot shape sketch extrudes cut through it. But certainly for our first feature, we're going to disregard those. We're going to intend to put them in subsequently using a cut extrude and then using a pattern as well. So we're going to imagine that this shape continues all the way along there. That's a continuous horizontal edge. Then it has these tiny little chamfers in the corners. You can see there's an annotation there saying 0.1 mil by 45 degree chamfer on 7 corners. So we're going to try and check out which 7 corners they are. So there's one there, one. I don't know whether there's any on there. So we'll have 1, 2, 3, 4, 5, 6. And then we have a 7th. But I think what we'll do is we'll disregard those in our sketch and we'll put them on using the chamfer tool afterwards, because that's a nice way of keeping them all. Given that they're all the same scale, they're all 0.1 chamfers, it would be nice to self-contain them in their own feature, so that if that 0.1 ever changes in the future, it's an easy job just to go into the chamfer feature, change that value or change that value of the angle, or maybe delete one of the edges that they've been applied to. And yeah, it keeps them more self-contained. So we're going to draw the rough outline of this. Next thing we have to do is decide where the origin's going to be. I'm going to decide to put it here. So in line with this initial edge, given that the drawing has used this as a datum edge essentially, it hasn't actually specified that using the correct symbol for that, but it's essentially taken all the measurements in a horizontal sense from that edge there. So I'm going to put the datum point right there. Then I'm going to have a look at what's this initial diameter to this edge here. So it's nominally it's 19 mil diameter. So I'm sort of ready to start sketching now. So I'll keep that for reference, and then I'll select the revolve boss base feature. As I've already said, this one's going to be a revolve. Then I've got to sort of arbitrarily pick one of these planes that the initial sketch is going to be on. I think I'll pick, what am I going to regard as the front? I think I'll pick the right plane. The reason I say that is that cross section that we're looking at there, I would say that we're looking at the part from the side there. I would regard this as the front or the back. So yeah, but that's sort of an arbitrary call. It's up for debate. So I'm going to use the line tool. Initially, I'm going to lock one end of this line onto the origin, and I'm going to go vertically upwards. Now, this is the edge on our drawing, which is that edge there. But yet I'm drawing upwards from the origin. And the reason I'm doing that is I want to get the approximate scale of this edge. So this edge approximately wants to be about just under 10 mil long, because our diameter eventually is going to be about 19. So yeah, if I'm in that ballpark, I'll be happy. So I'm going upwards. I want to hit sort of just under 10, around about 8 will do for me, maybe a bit less. So again, this is to do with getting the rough scale of your initial sketch approximately right. And then what I might do is zoom in a little bit there, because when I've sized that more or less correctly, I've realized that I'm actually way too far zoomed out for my own purposes. So then I'm going to draw the first edge in. So I'm going to make an edge about 2 mil long in a vertical sense. Then I'm going to come in slightly, probably just under 2 mil. So again, now I'm into the sketch itself. I'm just kind of getting it visually correct. I've got one initial edge that was around about the right scale, so I'm just trying to sketch it as I'm seeing it in my reference drawing there. I'm not trying to hit the exact dimensions now. And then I'll probably go into about there-ish, and then go back again, and then back to about there. So I'm looking to draw something around about that sort of shape. So again, if we go back to our reference, what we've drawn there, if I can kind of get these two things on the screen at the same time, is, it's easier said than done. Try again. So you can sort of see, I think mine's a little bit too long in the neck here. So this section's become a bit too long. But essentially what I've drawn is that shape there. And then back, and then it has that big sort of opening in the mouth there. But I've put an extra line in there. So that line there that I put in initially, just to allow me to get the scale of my sketch approximately right, I'm going to delete because I don't need it. So if you want to delete a sketch element or entity, you just click on it and then press the delete key. So now what I'm going to do, because this is a revolve, it has a special requirement that you don't get in most extrudes. That requirement is you must put a center line in the sketch. So center line is a different line type. So you get access to it in the drop-down menu of the line menu. So center line is in there. If you select that, and we want to lock it onto the origin, because the center axis of our revolve that we're about to create is in line with the origin because of the way that we've set the sketch up. So I'm going to click on one end of the line on the origin point to lock that on there. I want this center axis to run horizontally as we've drawn this sketch. So I'm just going to let it lock itself onto that plane and then click. And then I'm going to hit escape to get out of that tool. Now with these center lines, there is no requirement to give them a length. Technically, these center lines run to infinity in either direction. The length that's shown there is just for sort of illustrative purposes in my sketch. So the system doesn't hold you to defining the length of center lines. As long as their position is defined, yeah, you can leave the length underdefined. You can put a dimension on there, but it's not really required. So now we're going to start dimensioning our thing. If I can get this to... that's much better. So yeah, hopefully you can see both of them there. So what I'm going to do is I'm going to put some of these vertical dimensions in. So you can see that they all begin at this edge, so I can handily use this front plane as my reference, and then click on elements that I want to dimension to. So that's, I've gone a little bit too big there, or quite a lot too big, so that was 0.8. This is a really tiny little part. And then we've got 3 mil. So again, from this edge here out to this edge here is 3 mil. And then the next edge is 4 mil. So there's a feature here that I haven't quite realized was there. There's a little shelf there that kind of drops in. So that's okay. I can come back and correct that. So it's just due to the fact that this PDF's been scaled and the drawing itself isn't terribly high resolution. It's easy to miss. But yeah, there's a shelf in there which is a smaller diameter. So if I want to, I can stop now and correct that, or I can put these dimensions in and then I can add it in afterwards. I think I'll continue with my dimension in and then I'll come back and add that in. So yeah, so I want to keep the Smart Dimension tool on that vertical plane to the end of the part there. Place the dimension to make sure that they're quite neat how they're placed. 9.8 is the overall. So now, at least in a sort of horizontal sense, the scale of this thing is about where we need it to be. So I think I'll correct that little problem that we spotted there just by, I can just jump straight into the line tool if I want, just by clicking on the line tool there. And then what I need to do, if I zoom in a little bit here, is at about, let's say, that point there, I'm going to start a new line, drop inwards slightly, move along, click again, and then come back out to about there. So yeah, that's more or less the size and scale of the feature that I need. So I'm going to hit escape on the line tool, and then I just need that trim tool again. So if we click on trim, power trim is the type of trim that we want, and then just draw that freehand line till it touches the sketch line that I want to chop or I want to trim back, and then I should be looking at that. Then okay the trim tool so that I get out of there, and then what I can do is put my missing horizontal dimensions in now. So get the Smart Dimension tool to that edge there is 4.8, so 4.8, and then to the other edge is 8.8. So if I, and again, if you want to pay sort of reasonable note to how you're placing your dimensions, don't mess up the sketch too much so all the dimensions are on top of each other, because you're kind of only making your life more difficult. You want to try and keep them as neat as you can, the positions of them, that is. So 8.8 for that one. And then in a vertical sense, we've kind of finished there. So we want to put some diameters on. So I'll just zoom out a little bit. And when you're creating a revolve, there's a particular sort of trick that you need to be aware of that allows you to create these diameter dimensions. Because you can see we've kind of drawn or sketched only half of our part here. Because this rotates around the center axis, you end up with another piece of material down at the bottom here. So it starts off up here, rotates 360 degrees around the center axis, which means we should technically, logically be drawing something down here as well. But that's not how you set a revolve up. You just draw the half profile. So you draw half the profile, and then when you come to create the revolve feature, it then rotates it around that center axis. So how do we put diameter dimensions on a sketch which is only the half profile? Well, the first thing we've already done, which is that we've put a center line in our sketch. Then with the Smart Dimension tool, you click on the center line, you click on an edge or a point that you want a dimension to, so maybe that edge there or that point, doesn't make any difference. And then, so that would be the radius, but if I pull my dimension over that center line, it magically becomes the diameter. So as long as you've got a center line in your sketch, you can use that behavior to allow you to create diameter dimensions for these half profile shapes. So yeah, so let's place that one. It's nominally 19 mil. So we'll enter that. I'll just move this reference window out of the way a little bit. Then we'll do it again. So still got the Smart Dimension tool. Click on the center line. Click on that edge or that point even. You could do it to the point if you want. Click on either one and then drag that dimension back over the center line. And you get the diameter rather than the radius. And nominally, this is 21.9. So let's keep doing that. So you can see the center line begins at the origin there. There isn't a center line here technically. I'm just clicking on the center plane there. So don't make that mistake of clicking on the center plane. If it's easier, you can temporarily hide the planes just by clicking on that eye icon at the top. So yeah, let's add the other ones in pretty quick. So what's that one? That one's just a nominal 14 there for that section. Nominal 14 and then a 15.9 down at the other end there. So that one is 15.9. And then we've got an internal one, hopefully there. That's probably defined on a separate view. So, but we have got a 3x45 for this feature here. So because we've sketched that, could be regarded as a chamfer feature, essentially. In fact, let's do it that way. So we're not going to put that in the sketch. I'm going to delete that in a second. And what we're going to do is we're going to run our part down here vertically and out here or as horizontally so it meets. And then we'll add that in as a chamfer feature in the feature manager. Which again, it's a different way of doing it, but it allows you to manage these sorts of features a lot easier rather than trying to bake them in the actual sketching process itself. So I'm going to escape my Smart Dimension tool. I don't need that anymore. I'm going to click on that edge, hit the delete key, and then in the trim tools again, which we've kind of used just recently, we want to select the second one down, which is the corner option. And what this will allow us to do is pick two lines that will intersect at some point, and the corner tool will extend them until they do meet each other, until they do intersect. So that's quite a useful tool. So we don't need any of the trim commands anymore. We can close that dialog. And then let me see if I can search around and find what is the diameter on the inside there. It may not even be on the drawing. I think it may be missing from this drawing, so that's a problem. I think we're going to have to make it up. So that is an error. No doubt this drawing will have been revised after this point to actually correct that. So let's just put a figure in there, something that looks about right. So somewhere in that sort of range. So let's call it 11 mil. So at that point, we've fully defined this revolved sketch. We have formed a closed boundary. There's one last thing that it would be nice just to tackle, and that is this drawing is giving us dimensions that actually have tolerances after them. So you can see that dimension there has plus or minus 0.05 of a mil on diameter. So does this one, and so does that one as well. So at this point, even though it's a more sort of advanced skill, it would be nice to see how to store those tolerances actually inside the part itself. So inside your part models, you can keep track of what tolerances any given feature needs. And it's a pretty easy thing to do. So if we escape out of all Sketcher tools, and then in this instance, we've got 3 separate dimensions, but they all have the same tolerance value applied to them. So you can see all 3 of these have got the exact same tolerance value. So the nice thing about that is we can select all 3 of them and just apply the tolerance once, and it will get applied automatically to all 3. So the way that you select a dimension as opposed to go in and actually edit the value is you click anywhere on that dimension that isn't the value itself. So for our purposes, this arrow head or arrow leg is probably the easiest thing to click on. So we'll click on that one, hold down Control like we do when we're multiple selecting geometry, click on that one, keep Control held, and we'll click on that one as well. And then whenever you click on any dimensions, you get this dimension dialog on the left-hand side that allows you to make changes to that specific dimension. And the thing that we want to look at is this, tolerance or precision of the dimension. Currently, the tolerance type is set at nothing. So what that means is none of these manufacturing tolerances have been applied to these dimensions yet. They're what's known as a nominal size. But we want to apply a plus minus tolerance type. So we'll have a look in there. So given that our pluses and minuses are by the same amount, so they're both by 0.05, so 0.05 over the displayed value is acceptable, and 0.05 under the displayed value is also acceptable, we could apply what's known as a bilateral, which essentially achieves that. So you can see there, as I select bilateral, a few things happen. Because we haven't set a value yet, I'm getting 0.00 and 0.00 displayed after all my dimensions. So we've activated the tool, but we've not put the actual tolerance range that we are going to find acceptable to manufacture this part within. So now we can enter that in the plus and minus entry boxes here. So plus 0.05, minus 0.05, and you've got to kind of click back out of the box or press enter to get the display to update there. So essentially we've done it. We've kind of stored what those specific faces, what their acceptable limits are for manufacture. So we'd be happy with this if it was up at 19.05 diameter, and 18.95 as well would be acceptable, and anywhere within that range. But we'll come back to tolerances and precision and stuff like that later on. It's a nice little introduction to just to show you that it is possible to store them within the part itself. Because the other option for producing a drawing like this is to just manually add these in at the drawing stage. But that's by far the least preferable way of doing it. By far the best way of keeping track of them is to bake them into the part itself, so that then any changes that you want to make, you just refer back to the part itself rather than adding them in sort of willy-nilly as you create the drawings. So yeah, so that's a little bit of an aside. It's not specifically to do with revolves, but it's a nice little intro into part tolerancing and dimensioning. So yeah, we're happy with that sketch. It's fully defined. We've put a center line in, which is the extra check to do when you're creating a revolve. And we've got a closed boundary, so we're good to go. So accept that sketch, click on the OK sketch icon at the top right. The system will rotate your view round like it does when you're creating an extrude. And then you can manually rotate your view to try and get a sense of what it's going to create for you. This looks all right for our purposes. So we can OK that. Before we OK it, a few things just to take note of. The first one is there's a box highlighted in blue there, which if you hover over it, the tooltip tells you that's the axis of our revolve. So what it's done there, because we modeled that center, because we sketched a center line in our sketch, it's happily accepted that. So that's that reference there. Line 12 was the center line. So if we hadn't modeled a center line, it wouldn't throw an error, but it wouldn't show us a preview either, because it would be waiting for a little bit of input. It would be saying you need to select what of these edges that you've sketched you want to use as an axis. And that's why it's far, far better practice to include a center line in your sketch when you create a revolve, because the system will then auto accept that as the axis. A few other things which aren't really relevant to this example, but we'll have a little play. By default, it rotates your profile through 360 degrees. You don't have to accept that. If for whatever reason you want to have a profile that doesn't quite rotate all the way around, you can do that as well. So you can see I've reduced it by 1/4, so you can have whatever amount of revolution that you need around that center axis. The other thing, it has those similar options that the extrudes have, whereby you can flip the direction. So there's similar sort of flip direction button that you can do there. There's that similar mid-plane option in there as well, which can be useful if you want the sketch sandwiched in the middle. So yeah, there's a few different options in there. We're not going to run through them all, but yeah, there's methods of sort of playing around with the setup of that, which will get you all these different shapes. But I've just returned it to blind. The direction's kind of irrelevant because we're going 360 degrees, so it doesn't really matter which direction. But yeah, blind value, 360, click on OK. So that's our base part that we've got now. So just quickly looking back, I think we're just about to run out of time. If people want to save that would possibly be good, and we'll drop back into that next week. So file menu, click on save, give it a name, revolve example or something along those lines might be a good idea. And then, yeah, we can pick that back up next week, and we'll have another look at, or we'll have more of a look at some revolve features and have a little practice at those as well before moving on to some of those other tools. Hole Wizard, I think we'll move on to. Using patterns, I think we'll move on to as well. So yeah, I think we'll wind it up there. I think we're bang on time now. Yeah, it's just gone 3 o'clock. Okay, so I'll see you next week, and hopefully me and Tarson will figure out the registration code system as well. Because yeah, neither one of us can make it work at the moment, but we'll get back to you. Either he will or I will. So yeah. All right, I'll see you next week. Bye.